But I want you to write down these basic trig identities just to, you know, jar your memory. You don't need, I mean, I'm not going to test you on them, but you might have a homework question or something with them in, and those are the basic ones. Those are the ones that are used the most. So what I thought I would do, I thought I would pull it in and I'll put it on the board, on the Teams board. I'll put it up after class just in case you want to print it out. Go ahead and write that down, and then I'll pull in the examples we're going to go over to transition from what we reviewed the other day to what we're doing now. What are y'all talking about, Dr. Anderson? Who's Dr. Anderson?
That's my wife.
Oh, she teaches?
Yeah, she taught at North Greenville University for 7 years, and then she just started at Clemson last semester teaching biochemistry there.
What class, though? There's a ton of biochem classes.
Well, there's only 2 at Clemson. It's her and one other, well, maybe 3. There might be 3 different classes, but.
So she just teaches the gen biochem class.
Yeah. Just general biochem.
She probably teaches for the non-majors then.
Yeah, that's what she does.
Okay. So I wouldn't have had her.
Okay, get that written down. Let me know when y'all are about finished. I got a couple of questions sent to me. Thank y'all for sending them. That means some of y'all are paying attention. If y'all want to, take a picture, and that way you can write them down as we go, but give y'all about another minute.
This was my hardest section in trig, was the trig identities.
Well, yeah, the second section is usually, the second unit is usually the hardest because you don't do much math. All you do is the identity puzzles. That's all you do, proving this identity and checking this identity, and it's kind of cumbersome.
Well, the funny thing is I didn't really grasp the identities well until I started using them in the later sections in trig.
Yeah. Just like you don't understand algebra until first variable calculus.
Mm-hmm.
All right, so here we go. Let's go ahead and start. And I just wanted to show you those just in case you see some homework problems, because we're going to be transitioning from the review section, which is algebra and polynomial functions, into the radical functions, the rational functions, the exponential functions, the logarithmic functions, and the trig functions, because you are going to be taking the derivative of all these functions. And you have to make sure you understand what kind of functions they are. All right, with that being said, let's go ahead and bring up the handy dandy document camera. And with that, we'll go ahead and do this review question. Well, there it is. Come on, you can do it. There we go. So let's go ahead and do that review question. That'll be worth at least 4 test questions or 4 homework questions because I made 4 compositions. So go ahead and do that. So this one, I'm going to rewrite F with a big set of parentheses. Here, I'm going to rewrite G with a big set of parentheses. Here, I'm going to rewrite F with a big set of parentheses. And here, I'm going to write G with a big set of parentheses. Here we're going to plug in 1 over x. Here we're going to plug in 4x squared minus x. Here we're going to plug in 4x squared minus x. 4x squared minus x. And here we're going to plug in 1 over x. All right, do the algebra. So no classes tomorrow. Yay.
Does anyone know how to get this little bar to go away? Where it says it's recording and the camera and the mute and all that stuff?
There should be a button that says dismiss.
What'd
No,
you say,
not
Miss?
that one.
You just click on the actual screen itself, it'll disappear.
Thank you, Miss Black.
Yes, thank you. Because I couldn't see that bottom problem. So thank you.
It took me 2 days to figure it out, and then when I did yesterday, I was so excited.
Well, mine keeps coming back.
If you move the mouse, it will.
Yeah, I was gonna say mine's doing it when I move my mouse.
All right, so that's going to give us the first one. We get 1 over x squared, which is 4 over x squared, minus 1 over x. Now, of course, you can get a common denominator. I'm not going that far, and I don't care if you do either. Remember, this is just so you can remember the algebra. This, pretty much that's the answer there. This is going to be, shortcut number 2. So that's going to be 4 times 16x squared minus 8x to the third. Y'all check my algebra there.
Would that be x to the 4th?
Yeah. Well,
4x squared times 4x squared, 16x to the 4th.
yeah.
Yes.
I was on the second one. Thank you. And minus be plus x squared. And then that's going to be 64x to the 4th minus 32x to the 3rd plus 4x squared minus 4x squared plus x. Y'all check me.
Yep.
Looks like 64x to the 4th minus 32x to the 3rd plus x. And 1 divided by 1 over x is x. Because you multiply by the reciprocal. So that's a little review of your composition of functions that we went over the other day. Y'all think we need to go over another completing the square?
Probably. Those were always my Achilles
Yes.
heels.
Okay, let's leave it up to the class. Yes or no? Go ahead, type it in. Completing the square. Do we need to do another completing the square? Si, senor. Okay, well, I guess that's, yeah, y'all
I
suck
think that's
at
pretty
it.
definitive.
Y'all pretty much suck at completing the square. Okay. Well, we're just going to waste our time doing a level 1, so let's at least do a level 7 or 8 or 9. Make y'all cry a little bit. Right?
Sure.
1/3 x squared plus 2/5 x minus 1/5 is equal to 0. Now we're going to do everything. So make sure you give me a vertex. Make sure you give me x-intercepts. Make sure you give me domain, range, increasing and decreasing values. And if you can't do it, just consider yourself what? A failure. So I'll go ahead and start you off for those of you that really suck at it. 1/3 x squared plus 2/5 x plus blank is equal to 1/5 plus blank. I'm going to divide. Now I'm going to put this in. When I factor out something, what are you doing? You're actually dividing, right? So I'm going to put a 1/3 right here outside the parentheses. But right here, I'm going to divide by 1/3, and I'm going to divide by 1/3. And of course, 0 divided by 1/3 is 0, so I'm really not worried about that. But what that does is that gives me, okay, that's x squared, because that cancels. And now I got to go over to my margin and do 2/5 multiplied by, what's the reciprocal of 1/3?
3.
3/1, so that's 6/5 plus 6/5 x plus blank is equal to 1/5 plus, and whatever you factor out on the left side, you got to multiply by that right side blank. Now I could derive that and show that to you, but it would be better for you to just believe me, okay? Because technically this blank comes from over here, and whatever this is, plus and minus blank, that's factored with that, and with the derivation, this one you have to multiply by that. Just take my word for it. Now I got to complete the square. So now I take 6/5, divide by 2/1, and square it, which is 6/5 multiplied by 1/2 and square it. 6/10 is 36/100. Does anybody notice how I did that? Somebody tell me how I did that. Describe to me how I did that from left to right.
You multiplied 6/5 by the reciprocal of 2.
Yeah, you're explaining it. That's not what I want. I want you to tell me what I did. Okay, don't explain it. Tell me what I did. Why did I showed it in what?
Order of operations.
Order. That's a good word. Order. I showed each what?
Operation.
Step. Real simple step. I showed each step. Now, why is that such a big deal? Because some of you, especially the guys, y'all think y'all can go from this step to this step in the bat of an eye. And you can't, unless you're Rain Man. And if you're Rain Man, you'd be in Las Vegas. You wouldn't be at Tri-County Tech. So you're not that person. So you can't go from this spot right here to this spot in one blink. So don't try it. All right. So if you
Can you
suck at
simplify
fraction,
the
Say it again?
36 over 100? Like,
I
can you
didn't hear
simplify
you.
36 over 100?
I didn't hear you.
Can you simplify the 36
Yeah,
over
you can
100?
simplify all you want to, but I'm not.
9 over 25.
I'm not gonna change horses in midstream right now, okay?
Okay.
Because I'm in explanatory mode, okay? You
All right,
can
okay.
reduce, and that's fine, okay?
Yes, sir.
So I'm gonna multiply over here by 36 over 100, and you can reduce it down to what? 9 over what? 25 or something like that. Okay? I have no idea. So our final, before we start getting the vertex and everything, is 1/3 parentheses shortcut number 1 x plus, and if you want to change that to, I left it here because it's easier to take the square root, but you do what you want to. That'd be 6 over what? 10, which is 3 over 5. Equals 1/5 plus, and I'm going to put that 1/3 here, and that's going to be 36 over 100 is going to be, what is that? What did I say it was? 9 over 25. Somebody help me out.
Yes, 9 over 25.
Okay. So now we got 1/3 x plus 3/5 quantity squared is equal to 1/5 plus 1/3 9 over 25. All right, now I'm going to let y'all take it to the next page. Take it to the next page. And I'll leave that right there for y'all to catch up. Okay, so I'm going to take it to the next page, and I'm going to rewrite it. 1/3 x plus 3/5 quantity squared is equal to 1/5, and what is that, plus 9 over 75? And 1/3 times x plus 3/5 quantity squared is equal to, well, I'm going to change that. I'm going to change that 5 into 75. How many times will 5 go into 75?
15.
15 times 1 is 15. So that changes into 15 over 75 plus 9 over 75. And that's going to give us 1/3 x plus 3/5 quantity squared is equal to, dang old, what is that? 24 over 75?
Or 8/25.
24 over 75, right? I mean, if you just add it, yeah. Now, if you want to reduce that, that's fine. Reduce it. I don't care. I'm not going to worry about that right now. Because I got to still deal with this 1/3 right now, and that 1/3's got to come over here, so something's going to cancel out anyway. So over here, I got my vertex of -3/5, comma, -24 over 75. And yes, you can reduce that down to 8/25 or whatever it comes out to be. Now I'm going to divide by 1/3. I'm going to solve for x now. Multiply by 3 over 1. 25 gives us 24/25. X plus 3/5 quantity squared is equal to 24 over 25. Look at there. We got a perfect square on the bottom. X plus 3/5 is equal to the square root of 24. I'll deal with that in just a minute, over 5. Now, it doesn't take a rocket scientist to know what the square root of 24 is. What is it? 4.9, Hubert. That's right, class. So that's equal to 4.9 over 5. So now our x-intercepts is equal to positive or negative 4.9 minus 3 over 5. And somebody tell me what $4.90 minus $3 is. That's $1.90. And $2 divided by 5, or $1.90 divided by 5, you know what that comes out to be. $2 divided by 5, that's dang old what? 20 nickels, that's 40? Something like that, or 4, I can't remember. You figure it out. And then I'm thinking of nickels, I'm sorry. And negative 7.9, negative 7.9 over 5. Well, 5 will go into 1, 5 won't go into 1, so that'd be 0.3. I'm thinking, what, 3.8 or 3 what? 3.6? Somebody check my math. I was thinking of 4. And negative 5 will go into 7 one time, and 29 will be 5, and then 8. Somebody check. Somebody on the calculator drill team, help me out there. Nobody's on the calculator drill team? That's a good thing. So, our y-intercept, ding, 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 is negative 1/5. So, negative 1/5 is right in there. We've got a negative 3/5. Golly, that's what, negative 0.015 or something like that. Yeah, that's, yeah. No, it'd be 6/10, 0.6. Negative 0.6. And this is going to be negative, something's not right. Hold on. I know. Negative 24. God, that's, somebody give me that. What is negative 24 over? It'd be right in here because it's going up, so it's down right in there.
It's slightly larger than 3.
Yeah. And then we got a x-intercept of 0.36 to the right and negative 1.58 to the left. So looks like that. And we've got domain is all real numbers. Range is equal to negative 24/75 to infinity. We're decreasing from negative infinity to negative 3/5. And then we're increasing from negative 3/5 to infinity. Line of symmetry is the x is equal to negative 3/5. Now you can also calculate a drill team. You can put that in your calculator and graph it out and do a trace and see if your answers are correct. So make sure you do that. Okay. So that's a little bit of review over the review. All right, let's throw something else out at you. Let's see how many of y'all remember how to do something like this. Tell me if this function is odd or what?
Even or neither.
There you go. Well, I can tell you right now it's even, but you got to prove it to me algebraically. Okay? So prove it to me algebraically. If you don't know, just sit there and pretty much feel discouraged. Does anybody remember the rule for even?
Yeah.
What is it?
Symmetrical across the x-axis.
Well, no, what's the rule? What's the algebraic rule? What's the formula?
Oh, f of negative x is equal to f of x.
There you go. Now I'm checking to see if it's even first because I see that the leading term is an even term. So that's why I'm checking for even first. So that means I got to put a big set of parentheses wherever there's an x and plug in what? Negative x. So I'm going to plug in negative x. And our answer is, that'll be x to the fourth. Negative x squared is positive x squared. That's going to be negative 2x squared minus 20. So it does equal f of x, which means this is an even function, which means that it is symmetrical around the y-axis. Now, again, you should look at that and you should say, oh, yeah, okay, I remember that. You're just basically proving what you assumed. Why did you assume that it was even? Because of that 4 right there. 4 is even. All right, you try this one. F of x is equal to 1 over x cubed minus x. What is the formula for odd? F of negative x is equal to the negative of f of x. So that means I'm going to draw our function with a big set of parentheses. And I'm going to plug in negative x. And that's going to give me 1 over, well, that's going to be a positive, but this is going to be a negative, so that negative can come out. We'll put it right there, negative x cubed plus x. Well, if I put a negative in front of this, what will that give me? Negative 1 over x cubed minus x. Now you could distribute that negative with the 1 and get negative 1 over negative x cubed plus x, negative 1 over negative x cubed minus x, or it would be plus x. The way it works out, the negative would come out, yes. It's odd. So odd means what? Not around the y-axis, but around the what? Don't say x-axis because we ain't even talking about hyperbola. What'd you say?
The origin.
The origin. So it's going to have some kind of funky looking like this. You know, it's going to be around the origin. Which, if you think about the ending behavior of a polynomial, let's talk about the ending behavior. What's the ending behavior of an even function? X to the second, X to the fourth, X to the sixth, dot, dot, dot. Yeah, man. What is it? What does it look like? Well, it's a parabola, right? And a parabola looks like this. Well, what is that? That is symmetrical. Those two ends are around, they're symmetrical around the what? What is it? Okay, I'm teaching.
Okay.
Check on the wall.
Okay.
Okay. He's outside somewhere or in the room. Sorry about that. Okay, so now let's look at x cubed, x to the fifth, x to the seventh, dot, dot, dot. What do those look like? Look at your family of graphs. And in behavior is opposite directions, and that's not symmetrical around the y-axis, it's symmetrical around the what?
Origin.
Origin. So if you really think about it, even and odd functions is not that big a deal. But you'd be surprised on how many people can't do them. Okay, that's a little bit new review. That's a little bit of what you might see in your homework. And here is a homework question. Crank that through the difference quotient. And those of you that forgot the difference quotient overnight, m is equal to f of x plus h minus f of x over h. Now I've got 352, so I'll give you a couple of minutes to crank it out. 2x squared minus 3x plus 5. What I'm going to do is I'm going to take my blue marker and I'm just going to put a blue set of brackets around this guy. And I'm going to put a red set of brackets around this guy. And I'm going to color this guy H. I'm going to color that green. So I'm going to bring down the brackets. And since I got to plug in something, I'm going to rewrite my problem with big set of parentheses, squared, big set of parentheses. That's going to be 2 minus 3 plus 5. And then minus, and then my red set of brackets. And what goes in the red set of brackets? Just f of x. So all you do is rewrite f of x. And all that is over h. If I give y'all 10 questions on the Unit 1 test, 4 or 5 of them are going to be difference quotient. They're going to be the short. This is probably the biggest one you're going to see. I won't give you a third, okay, because that is just, that's punishment. Okay, that means I don't like you. Okay, so I'm not going to do that to you. But we could do one if y'all want to do one. Let's put it to a vote. Like y'all are going to say. Like y'all are going to say, yeah, let's do a x to the 5th power. Pass. I'm good. Yeah, 4x. There you go. I'm good. So here we go. X plus h. X plus h And now our blue brackets is going to give us 2 times x squared plus 2xh plus h squared minus 3x minus 3h plus 5. And that's my blue brackets. Minus the red brackets. That really doesn't change much. It will in just a second. Because that negative is going to change everything. And the h is on the bottom. The h is really not significant right now. So that's going to give us 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 5 minus 2x squared plus 3x minus 5 all over h. And now let's take our red pen, or let's take our pink pen. Where's my pink pen? I done lost my pink pen. There it is. 2x squared cancels with that 2x squared. The 5 cancels with the 5. And there'll be another one somewhere, the 3x and 3x. And now I'm going to write everything in black that's left. 4xh plus 2h squared minus 3h over h. And that's going to be 4x plus 2h minus 3. Y'all check me. I think that's right. I can't remember who sent that question, but I hope that helps you. Notice I'm going to ask y'all something else. How did I do that problem? How did I do it? Y'all supposed to see a pattern here. Same way I did the other thing. Okay, forget it. Step by. Y'all suck. Step by step. So this isn't a pissing contest. I'm not trying to show off if I can get from here to here in one line, guys. Okay? We're not doing that. You want to get, what's your main goal? To get the correct what? Answer. So that means you need to do the work. Okay?
How does the h cancel the negative 3h and the h squared? Oh,
well, technically, this is what you do. I skipped a step. Factor out of h, and you get 4x plus 2h minus 3 over h.
okay.
That's
Okay.
what happens. Okay, you can do it individually, or you can do it factored out. I don't care. You get the same answer. Okay. Anybody else got a question? Next to completing the square, that's probably your next best bet for a test question. Here is a test question. I'm going to pull it up because it's one of those questions I don't use for test questions very much. Dang old paragraph and all the parentheses, and I don't care nothing about all that on a test. So let me just pull it up if y'all don't mind. Oh darn, Miss Hart got kicked out. All right, there it is. You write it down. If it ever comes up, there it is. I'll try to blow it up as much as I can. There, is that good? Yeah, Hubert, that's good. Thank you, class.
Much better on my eyes.
Well, then I'll make it smaller then. Now, this is a prime example of how the book or the test or the teacher can make you skip the question. Because I guarantee you some of y'all saw this question in your homework and you just skipped it. Somebody tell me why you skipped it.
It's a word problem.
It's a word problem and it looks what?
Hard.
Yep. But I can take the same word problem and change it into an algebra question, and you will be able to do it. Watch this. Let me make this smaller so you can still. I'm amazing, aren't I? I'm just amazing. Okay, so first of all, do they give you a function? Yes or no?
Yes.
So you just write f of x is equal to 26 minus 0.9t to the second power. Or you could even go redneck and say y is equal to 26 minus 0.9x to the second power. And go back to pre-algebra, and there's your x, and there's your y. And they're asking you A. What does A say? Now, I don't want you to, don't put your pinky up. What does A say?
Y is equal to 0. Or no, x is equal to 0.
Is it y is equal to 0 or x is equal to 0? X is equal to 0. So if x is equal to 0, what are they asking for?
Y.
26 squared.
So do it. So what happens to 0 with that 0.9? It
Goes away.
cancels out, Hubert. And 26 squared, I don't care about. Y'all can work your calculator. That's good. I don't care. All right. What's B? A said x is equal to 0. What do you think B says?
Y is equal to 0.
Y is equal to 0. So if y is equal to 0, what are you going to find?
X.
Plug in 0 for y. Now, how hard was that? That's why you've got to read the question and then say, you know what? This is at a nice banquet with tuxedos and the nice dresses, but what does it really mean? So plug in 0, 26 is equal to 0 minus 0.9x quantity squared. I'll do the first step for y'all. The square root of 0 is 0. There you go. And then, let's start to harden saying, you know what to do. So negative 0.9x, negative 0.9x is equal to negative 26. So 26 over 0.9. And that's C, because what is an appropriate domain for D? Well, D, basically, they say the depth of the water is at time is 0. So 0 to whatever that number is. What is 26 divided by 0.9? And what is 26 squared? Yes. What?
26.12, something like that.
Is that what this is? 26.12?
I'm just guessing. 26 divided by 1 would be
Yeah.
26. So
Yeah, so it's going to be a little bit more than that. Somebody give me the actual, just round it to a tenth.
28.8.
28.8.
0.9.
0.9. And what is 26 squared?
676 from the word problem.
Okay. Yeah. Okay. That's basically what they're asking. And it's a homework question, but not a test question, because unless I see an application that's needed in a future class with calculus, and yes, this is a nice little word application, but I'm more interested in you understanding the calculus. So I would just leave this as a homework question. Hope that helps whoever sent it. Now, I'm not going to have much time to go over what I wanted to go over today, but we're going to talk about the following. And this kind of plays into your family of graphs that I sent y'all yesterday. Radical functions, because right now we've been dealing up to polynomial functions. Okay, that's what we've been dealing with so far. And of course, you've dealt with those, and then your Algebra 2 teacher or your 102 teacher or whatever, pre-calculus, they said, here are some other where the domain is affected. The domain is affected here because you can't take the square root of a negative.
And you can't.
Here, you can't have 0 in the denominator, so you can't take the square root of a negative. You can't have 0 in the denominator, so I'm going to put the easiest way to do that is just put a red X through that one. You can't have 0 in the denominator. This one, basically, it goes on forever, but y cannot be negative, okay, because it's above the x-axis. So this one's okay. This one, you can't take the log of a negative number. And this is sine, but the domain is affected in some way, but most of the time it's all real numbers. I like to tell students that unless it's a log, a rational, or a radical, the domain is pretty much going to be self-explanatory. Okay, but you always set whatever equal to 0. So here I would set x plus 2 equal to 0 and solve. I would put x minus 2 equal to 0 and solve. I would say 4x is equal to 0 and solve. Now, what I mean solve? Well, you can take the log of 0, but you can't take the log of anything below 0. So you have to put it on a number line and see where it goes. So let's take the first one, because I think somebody sent a question about domain. It might have been in this class, or I can't remember. F of x is equal to 1 over square root of x plus 2. Now remember, I said you can't take the square root of a negative, but you can take the square root of 0. So therefore, you know what that means. X plus 2 is equal to 0. X is equal to negative 2. So negative 2 plus 2 gives you 0, and 0 is okay, but you don't want to check 0. Okay, here's negative 2 right here. That means negative 3 is right here, and negative 0 is right there. Now, negative 2 is green, because green is okay. I'm not going to use that green. I'm going to use this green. -2 is okay because -2 gave us a what? A 0.
Wouldn't that still
So
be
plug
undefined?
in. Say again?
Wouldn't that be undefined for this the rational?
Yes, it would. Thank you. But you can take the square root of 0. In this function, yes, but the domain is going to be, but you can take the square root of 0, yes. But as the function goes, that's the thinking part that I tell you. When you get to the end of the problem, you have to think a little bit. Okay, let me get there, okay? All right, here, -3. What happens when you plug -3 into this function? Somebody tell me what you get.
An imaginary number.
You get a negative number, and the square root of a negative number is non-existent. So this is bad. Everybody with me? So plug in 0. What do you get? You get positives, which is what? Good. So I can use all numbers above what number? -2. Now, to get to, is it Mr. O'Quinn that mentioned it a while ago? When you get to the end of when you start talking about the domain, you have to remember inclusive and exclusive. So the domain here, do we include -2? Yes or no?
No.
No, because as Mr. Quinn said, -2 will give us a 0, which will blow this function up. So we cannot use -2. So -2 gets a parenthesis, and we go to what? To this arrowhead. This arrowhead is called positive infinity. This arrowhead is called negative infinity. So our domain is -2 to what?
Infinity.
Infinity. Now here you had to think twice. You went ahead and you did the math, but then you got to the end and you had to think twice. You had to think, okay, well, -2 will give me 0. But what will it give me on the left side of -2? And what will it give me on the right side of -2? And that's where you find out what your domain is. And of course, then you think secondly, well, if that's a 0, you're going to get 0 in the denominator. That's going to blow that function up. So that means we're dealing with exclusive. You got to remember, I'm teaching a review section. This is kind of a review section because we hadn't got to the calculus yet. So I'm having to kind of knock 2 or 3 cobwebs loose with one problem. Y'all see what I'm trying to do here? I'm trying to, so x -2 in the denominator on the next problem, you know that that's going to be 2. So that would be all numbers except for -2 or +2, because you can have a negative in the denominator. You just can't have 0. Now, on the other ones, and this is where you get to the family of graphs, because when you get to the family of graph homework questions, they're going to ask you stuff like vertical and horizontal shift, domain, range. So if I give you this function, and I say, and I give you a note, most functions are regular, A is equal to 1. Okay, I got to give you that little note because you don't know if it's steep or if it's compressed or if it's stretched or whatever. This function is y is equal, f of x is equal to x squared, because I'm assuming that everything A is equal to 1. But if I take the same function and I do this, and I draw this same function in green right there, and I've just introduced a vertex to the equation, and instead of f of x is equal to x squared, I'm going to use the other green, sorry, because you can't see that green very well. Now I've got f of x is equal to x something quantity squared plus, since the vertical shift is up, I think that's 6, isn't it? 1, 2, 3, 4, 5. 5, and this is to the right, so that's negative 1, 2, 3, 4, 5, 6. Now you've got a different function. And you can do that with the absolute value. You can do that with the logarithm. You can do that with any function, trig function, whatever the case may be. Let's do it with a absolute value function. So the absolute value function, just like absolute vodka, starts with a V. F of x is equal to absolute value of x. So if I do this, give me my peach, my pink. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And I draw the same function right here. Then I know I've got to change this and say f of x is equal to some absolute value of x plus or minus something. And then this is going to be a negative vertical shift, so that's going to be minus 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4 is to the left, so that's going to be positive. 1, 2, 3, 4. So there's that function. Now, if you've had a good math 109, 110, 102, algebra 2, then you're sitting there going, oh yeah, I remember that, because it's always the opposite. The vertex is always the opposite sign. The horizontal shift is always the opposite. You should not be going, well, why is that negative? Why is it negative and it comes out to be positive? That's what you should not be saying. Okay, you should be saying, oh yeah, I remember that. That's the only time that the negative means right and positive means left, because they should have taught you that in some of those classes. All right, let's try. I'm gonna go with an easy one here because I don't want to mess you up or anything. So let's go with, let's just write it right here. No, I don't want to do that yet. I don't want to do that yet. We could go with, I don't want to do an exponential yet, and I don't want to do a logarithm because I'm going to wait till Monday to do logarithms and exponentials. Let's just stop there. Because that'll get you at least to 1.2. Okay? Who's got questions? Let me see if I can get the dojigger to work. Probably won't, but I'll try. Let me go ahead and turn off the recorder. Okay. Yes.